thank you so much. I appreciate it, the invite to be here, and I appreciate each one of you here. Thank you very much for having me. My background is in software engineering. So I started out as a software engineer and very quickly found my way into test automation. And I became an SDET, that's how I pronounce it, SDET, SDET, very early in my career and loved it. And so I want to talk with you a little bit today about the mythical SDET and unmasking it. Now I've got a picture of, I believe it's Poseidon here. I think he has a trident a little higher. I had to crop it, but I believe that's Poseidon. And he's not wearing a mask, but he is mythical. So we'll talk about the myth of the SDET. So let's start out talking about what is an SDET. So first of all, many of you know SDET stands for Software Development Engineer in Test. Software Development Engineer in Test. So this is a role. It's a person on a team that plays a certain role. And they are folks who have very strong software engineering skills. They can be dropped into a software engineering environment and be perfectly comfortable. They could ramp up very quickly if they were in production code, just like any other software engineer of their experience level. The difference is these folks focus on the testing world. So they look at the test infrastructure, they look at the test automation that's going on, and they look at making things testable. So as I mentioned here, an SDET is a software development engineer in test. So SDET, that's what that stands for. And these are folks who have the fundamentals of computer science in place, right? So for many, many years, the idea was that an SDET would have a computer science degree. They don't always have that these days, but they still have the fundamentals of computer science in their skill set and in their knowledge base. So when they have a conversation about APIs, they understand all the ins and outs of APIs. When they have a conversation about different tiers of an application and how it works, they understand all of that. They know how to work in the cloud. They know a little bit about AI, maybe, right? They know a little bit about security. They know a little bit about each of these different areas. But they are software engineers through and through. If you give them a problem, they're going to want to solve it with code like any other software engineer, right? They're going to look at efficiencies. They're going to think about how do we do this faster, better, more robustly? How do we do this in a way that we can repeat it quickly? They work, though, in the area of testing. And so they're able to do things like create unit tests, create integration tests, create EDE tests. Some may have experience with performance testing. Some may have experience with security testing. But personally, I look at those as being very niche and deep and rich fields. When I think about performance testing, I'll tell you most software development engineers don't have the ability to do that as much as someone who's specialized in that. And I think it should be specialized, especially when you talk about things like cybersecurity or performance. When I think about performance, I think about guys like Mark Tomlinson, people in his world, right? I sit down with him and talk about performance testing, and the way that he talks about it, I hardly even understand, right? He's got his own terminology, his own vocabulary. He understands how systems react when they're asked to perform well. He understands how to go about analyzing those things, troubleshooting them, digging in, creating solutions, workarounds for performance specifically, and load. Cybersecurity is much the same way. I worked with FireEye, I don't know if you're familiar with them, a number of years ago as a client, and they do security. That's their world, cybersecurity. They're called on by government agencies. They're called on by the largest companies in the world for cybersecurity. And I remember sitting on this team, being an SDET, being the consultant who was going to come in and work on test automation and making their product more testable, and realizing that I knew nothing of what these guys were talking about. All these folks on this team, they were all talking so in depth about cybersecurity, I barely knew how to even have a conversation with them. Those two areas, cybersecurity, performance, are deep and rich areas. Software development engineer and test should have some experience with that, some overlap, of course, but they're not going to be specialists in it in most cases. AI is much the same way, and I know that's something that's big these days, AI. People seem to think that AI is going to take care of all of our problems. One of the earlier places that I saw AI starting to be used in the software development world was in testing. And it was as if people thought testing was so easy that we could just apply machine learning and apply AI to it. And we would take care of the bottleneck of testing. We would take care of it right away. I don't see that happening yet. I haven't seen it happen within any product. I've seen a lot of products promise it, but I haven't seen it happen yet. Maybe it will one day, maybe it won't, but we're not there today. AI is being used all over applications though. So if you're a software development engineer and test, if you have that role, you have to have some knowledge of AI. You have to have some understanding of what can and can't be done with AI, maybe even how to test it a little bit. But in general, an SDET is a person who can do the things that are here. They can have the conversations about computer science. I remember sitting in an interview once as an SDET with a person who is an architect in test automation earlier in my career. And this person asked me, hey, what would you need to test a multi-threaded application? I said, a computer? I mean, I'm not sure what you're asking, right? And they said, well, wouldn't you need more than one computer? I said, no, why would I need more than one computer? And somewhere in his mind, he thought that because there were multiple threads, you'd need multiple computers to interact with it. But a multi-threaded application doesn't act like that. You don't have to have multiple computers. You have to have multiple threads or multiple processes, most likely, to be able to interact with that multi-threaded application. But I understood the fundamentals of computer science, and I was able to have that conversation. And that's one that if you're sitting around a table with your team and your application developers are talking about what they want to do and how they want to accomplish what it is they're trying to accomplish, you want someone there from the testing perspective who's able to dig in, go deep, and understand the nuts and the bolts of how we're going to test this, how we're going to access it, how we're going to build in testability. I want to talk a little bit about a couple other things that SDETs help with. So SDETs are going to help you with things like the testing infrastructure and the deployment infrastructure. These days, we talk a lot about that as if there is a person called a DevOps, and maybe on your team you call them DevOps. Maybe you call the entire team DevOps. And I know that that's a colloquialism, something that we use all the time. But DevOps in its truest form is a culture and a process. DevOps is all about a couple of major problems, one of them being reducing mean time to resolution. And what this means is when we have a problem out in production, or we have a problem even in an earlier system in the process, in the pipeline, how quickly can we resolve it? And getting that time shorter and shorter is what allows us to be able to put our products, our software products, out more quickly and satisfy our customers' needs or our users' needs more quickly. That's how we make sure that our software can respond to business needs, changing business environments, because in the end, that's really what it's about. If you're an executive, you're looking for how is it that we're going to make an impact with the business. SDETs help with that because their job is all about shortening software life cycles. They're trying to make those faster by making sure that we get faster feedback. These days, if you're not using continuous integration and continuous delivery, I consider it malpractice. You got to be using continuous integration and continuous delivery. I've heard all the excuses there are from my customers, whether they were consulting engagements or something else. And the ones that I hear the most are usually from a perspective of maybe a little misunderstanding about what continuous integration is good for. They'll say things like, we aren't concerned with a lot of releases, or we're only going to release one time per quarter, so we don't need to do continuous integration. I even heard one not too long ago, we don't have a lot of people working on this, so we don't have a lot of integrations. We don't need continuous integration. Well, I'll let you know, when I work on my side projects, I have continuous integration set up. And it's for me, even if it's just for me, because I want to know what's going on with my application. Continuous integration and continuous delivery using test automation, make sure that we know what's going on with the system under test, that we can get fast feedback, that we can understand what's going on with it. Software development engineers understand a couple other things as well. What do they do? Well, the number one thing they do gets back to what I was just saying, which is they write code to detect change. So again and again through test automation, I hear about people wanting to make sure that all the tests pass, all the tests are green, that we have lots of test cases, and that they're really, really fast, and that they take care of testers' jobs, that they do what testers did. That's simply not what test automation does for SDETs who have done this for a long period of time. SDETs understand what they're trying to do is to detect change in the code base, to detect change with the system. Someone makes a change in the code base. Did it do what it was supposed to do? Did it change something it wasn't supposed to change? Has another test failed? The quicker we get that information, the faster our software goes out. And the faster our software goes out, the more we are able to accomplish our business purposes. So SDETs also build tools for testability. So this is something that's lost many times when we're talking about test automation. People think in terms of test cases, they think in terms of scripts, they think in terms of bugs. But the more testable our code base is, the more we're able to test it. And the more we test it, the better the code base gets. And the better the code base gets, the higher quality the product is. The higher quality the product is, the less time we have to waste fixing things. So we want to enable higher quality and faster development. Software development engineers and tests can do that. Now, the other thing that you're going to be asking is, okay, that's fine, but where do I find an SDET? We said that these were mythical. Now, I don't know about you, but I've never sat with my laptop in the woods like this guy before, right? Like I've never done that. I'd be too worried about getting some kind of dirt or grime into a port there somewhere and the machine never working again. If you're going to find me in the woods, I'm going to be in camo about 20 feet up, but I'm not going to be using a laptop. But maybe there are some that live in the woods. Where do we find them is the question. And we're going to talk much more about this in the second part, the conclusion of this next week. And there are basically two alternatives, and they relate back to the way that you choose to do anything in your organization. So you all are executives, you know what those two things are. You build or you buy, right? Those are your two options for just about anything that you choose to do. And with SDETs, it's much the same, although I'll use the terms acquire or nurture, right? So we can either go find SDETs somewhere else, or we can nurture them to becoming SDETs, grow them within our companies. So I want to talk to you a little bit about what that means and who these folks might be. There are a few things that you just shouldn't do, some anti-patterns that I've experienced along the way, and I'd be happy to share some stories about that as we go along. Before I get too far into this, this is probably a good time to start typing up questions. If you have questions, take time right now and start typing them, because we're going to get to them in just a few minutes here. I very purposefully made this presentation about 20 to 25 minutes just to respect your time, because I know people have a lot of stuff to do and I want to get to the meat of this as quickly as I possibly can. But where do we find SDETs? So SDETs are software engineers, we talked about that prefer the test systems as their domain rather than application code bases. So these are folks who they could go do software engineering for applications if they wanted to. I've done that many times throughout my career, and I did it fairly well. I wasn't the best, I wasn't the worst. I was somewhere in the middle, maybe a little above the middle in some ways. But you know, these are folks you can drop into an application team, and they have all of the ability to do that. They just prefer the solution space of testing. These are folks who possibly were testers, but they have the skill set of a software engineer. Now that's pretty hard to find. Most testers that have been doing their job 3 to 5 years or more, they've had the opportunity at some point to go do coding, whether it was writing test automation, becoming a software engineer, whatever it was, they've had that opportunity. Many times they have that in school before they ever get in their career. Many times they have that opportunity on their own time. This is one of the greatest times in history to learn on your own. You can go out and learn just about anything you want if you're interested, just by going out and finding videos to watch, books to read, blog posts to read. Plenty of people out there trying to teach you things, and plenty of people who do it very, very well. So testers usually have opted out of coding. They've usually opted out of coding. And that's okay. Not everybody's supposed to code. Not everybody's built to code. There are things about me that are set up specifically for doing test automation and for this particular world. There are things that I don't do well. I can get along with being extroverted for a certain period of time, but I'm actually an introvert. So if I spend a lot of time with people, if you want me to be a salesperson, I'm not a sales guy. I'm not going to be able to do that and get along with it. I'm just not built that way. And testers many times are the same way. They may not be built to understand and to naturally want to interact with a computer in terms of programming. That doesn't mean they're not valuable, and that doesn't mean that they shouldn't be on your team, and it doesn't mean that you shouldn't use testers. In fact, none of what I'm saying here is meant to say, don't use manual testers. Manual testers, people who do hands-on testing work, are extremely important. And I'll tell you, there's a big difference between a below average tester, for instance, and a below average software engineer or SDET. And the big difference comes in productivity. If you have a tester who's maybe more junior, maybe they're not as experienced, maybe they're a little slower, they still move things forward. They still push things forward with your process. But if you have a software engineer who's a little below average and not as able, maybe they're a little junior or something along those lines, that person usually is a net negative on the entire software development team. Somebody has to go in and fix their code, fix their bugs, find their bugs, communicate about them, all of those different things. So you don't want to take a software engineer who was not good at software engineering and just move them over to an SDET. That won't work because you're still building software. It's test infrastructure software, it's test automation software, but that will still result in a net negative. You will not change that unless you change that person's skills or help them to develop in some way. You don't want to convert QAs to SDETs unless they're incentivized on their own. If they're internally motivated to do it, that's a great opportunity. When we motivate them externally, we usually end up with people who didn't want to be there in the first place. They went for the extrinsic motivations, the higher pay or the more notoriety or something along those lines. And it's just different. People generally are motivated and move better and do better when they're intrinsically motivated. So I would never suggest converting all QAs or all testers to software development engineers and tests. Finally, I said, let's go ahead and ask some questions. So hopefully you all have started typing a few up here. But there are a number of different ways to find people. So within a company, outside of your company, those are the two main ways. You're either going to train people or go find people for that. And this is something that I found doing consulting along the way. I would work with companies to try to solve their problems, help them solve their problems, help them set up milestones and plans for how they were going to move forward with testing and test automation. And they would come back to me and say, we need people. And so I started doing staffing as well. So if you ever need that service, that's there. But I want to let you know that this is my contact information. Software development engineers and tests are software engineers. If there's one takeaway, they are software engineers. They get paid like software engineers because they do the same set of skills. In addition to that, they have a deep understanding of testing. They work with software engineers to promote testability within the code base. They work with testers to ensure that they're more able to test applications and that the application is testable. They work to make faster life cycles by understanding change within the system under test due to coding. So once again, I'm Paul Merrill. I would love to answer some questions, Sri, if we have some.
Yes. First of all, a wonderful presentation, very succinct and, very, very well done, Paul. Really appreciate that. There is one comment here. It's more of a comment than a question here. So just want to read it out. Not all developers are meant to test either. I personally coded in the past and left it for testing, and in parentheses, or more precisely, when I coded, you had to test your own stuff. It's been decades. So I'm not sure if there's a question coming up, but I accept the comment.
And I'll add to that if you don't mind. Sure. It's an interesting perspective, and whenever people type these things, you never get the full understanding of their context and what's going on and all that. I would disagree slightly in that I think if you're a software engineer, you do have to be able to test. You have to be able to make sure that your code works. If you don't, what are you doing? But they're not built to sit down and do tests day after day after day in a manual way. If that's what the person is saying, I totally agree.
Yes, definitely, definitely. Thanks for adding additional color here, Paul. Appreciate that.
Yeah.
There is also one question here from Larry, I believe. What is the best way to find SEs, I believe software engineers, with the test system preference either internally or externally to your org?
Yeah, the best way to find those. That's a really good question. So internally or externally? Well, externally, you're usually doing a search, right? So you're doing some kind of hiring search. What I found is the way that you attract people, high quality, high skilled people, is number one, make sure that your environment is suitable to people like that, right? So create an environment that people want to be in. And that might mean that you're using the latest technologies because that's what interests people who are very good at technology. It might mean that there are other things about your culture that are very important to you and would be important to other people. So number one, create an environment that other people want to be in. Secondly, broadcast that. So whether it's by meetups, whether it's by something like this with Inflectra.com, the way that you've got these sessions set up, I'm sure that you have future employees who watch these things and they say, what is Inflectra really about, right? And I hope that people look at the same thing for Beau Fairmont and think, hey, what is it really about? So broadcast what your culture is about through things like this, meetups, culture, blog posts, whatever it is. Internally is a little different, I guess. So you're going to have to search those folks out. With large organizations, that's a different problem than with smaller organizations. With large organizations, you're really going to have to do some research and create some type of campaign internally to find these folks and to figure out if they're around. And there are all different sorts of problems within larger companies that you have to work through for that. With smaller companies, mid to small size companies, you usually know who the ones are that would want to do this. They've either told you, they've told their manager, they've told their manager's manager. Ask your managers. You all are executives I'm expecting. Ask your managers and ask the people on your team, who is it that you think would fit this role?
Definitely, definitely. And especially with the remote ways of working, lots of people are actually in the woods these days. So
they might be in the woods, yeah.
They might be in the woods.
They might be.
But that's good. So one more question, Paul, because in the interest of time, I'll just ask this one question. There's a question here like about why wouldn't I just use software engineers instead of hiring SDETs?
And that happens, right? That happens. That was a big part of extreme programming. And I think I mentioned that earlier. Extreme programming was an agile methodology that kind of came about around the same time as Scrum started in the early part of the agile world in the late 90s, early 2000s. And it specifically asked software engineers to create test automation and to work that way. You can do that. You can absolutely do that. And I think that some type of testing, like I mentioned, should be a part of a software engineer's job at some level, somehow. You can certainly do that. What some companies have found, like Microsoft that started this back in about 2007 and Google who followed shortly after, was that there was a benefit to having people specifically focused in that space and writing testable code. It can be two very different sets of code. It can be two very different professions, two very different types of thinking to do that. It's kind of like saying, why don't I use my software engineer who does the accounting part of the application to do the analytics part of the application as well? Well, you have two different pieces of code that need to be worked on, and maybe it's important to split and get a little specialization there.
Absolutely, absolutely. Yeah, I remember that extreme programming time frame. Yeah, thank you very much
Yeah.
for bringing that reference, Paul. So one more question that just came up. With that, I'll probably kind of wrap it up if that's okay.
Sure.
This is more about, can you share some key soft skills that SDETs should possess? Maybe some examples.
Yeah, so I think that's a fun question. I think that's an interesting question because when we start talking about technology, nobody wants to talk about soft skills, right? I mean, this is one of the things that I love to talk about. It's just really hard to sell the soft skills. So yeah, I mean, number one, a lot of times, unless you have a very large organization, you're not going to have very many SDETs. So they're going to need to have some level of leadership, at least the part that is leading themselves. They're going to have the ability to lead at least themselves. It's better if they can lead more than that. So leadership is one part of that. Soft skills, there's a lot of communication. So anybody who's been a part of testing or software engineering understands that, I believe that communication is much more important than just about any other skill related to software engineering and to testing. You have to be able to communicate at an extremely high level, written, verbally, and every other way that you communicate. Those are two that I would say to begin with. An analytical mind is very helpful. The ability to build things. Teamwork is always helpful. You know, I like working with positive people. It helps me. It helps them as well, I think. You know, positivity, I think, is always good, but that's a preference more so than a requirement for this position. But communication, leadership, teamwork, those would be the biggest ones, I would think.
I think you answered that very well. I was thinking, like, where would we even start with the soft skills? It's a wide, big, checklist we can go with. But I think leadership, teamwork, and, the analytical mindsets and stuff like that, those things are very well said. Communication.
And what would you add, Sri? What would you add to that?
So some of the things that I would add is more or less the same lines, but more about emotional intelligence, empathy, trying to, not necessarily understand what the other person is saying, but, go a little bit deeper and understand the why and, stuff like that, the emotional intelligence. And also with the communication, I add one more flavor, like nonverbal communication. What are they saying is one thing, but what are they not saying? But that's more important as well,
Sometimes that's right. Sometimes, I love emotional intelligence and the concept of that. I think it's extremely important for communication, where it was probably kind of embedded in my mind, embedded in just this wrapped up idea of communication. But absolutely, I mean, I think, when we're working with people day in and day out, you're going to see their best. You might see their worst. And you got to be able to kind of work with that, because we just aren't robots. Like, we don't just come in and every day are at our best. You got to find a way to understand where somebody is emotionally to get them to a place that they can be proficient and helpful.
Absolutely.
So I'm with you. That was a good answer. I appreciate that.
Absolutely. I mean, it's not different from what you said, but it's just different flavors of, what we are trying to, do as well. But at the end of the day, I completely agree. You even mentioned, like, the acquire, nurture. You can acquire, but still you have to nurture them. And this is all about that particular aspects of it. I really appreciate that. And I'm sure there may be other questions, but at this particular point, Paul, there are no questions. So yeah. I will, thank you again for one more time for the wonderful discussion here. Again, thank you, Paul, for this wonderful time.
Thank you so much for having me. I appreciate it. You all have a good day.
Thank you. Have a good one, guys. Bye-bye.